The ME3840B is an easy-to-operate, low-frequency broadband EMF meter that measures AC electric and AC magnetic fields. It can also be referred to as an AC electric field meter, Tesla meter, or Gauss meter. This meter is designed to measure the invisible pollutants that radiate from electrical wiring and devices that use AC power. The ME3840B measures frequencies between 5 Hz and 100,000 Hz, or 100 kilohertz, in 4 ranges. The first frequency range covers the entire band of the meter, which is useful for detecting all sources of EMF. In this range, the meter must be very stable. It is recommended to use a tripod when measuring in this range. The second frequency range allows the meter to detect only frequencies of 16 Hz. In Europe, this frequency, which is actually 16.7 Hz, is used for the AC power supply to many electric trains. This frequency is not used in North America. The third frequency range is the default range, which is useful for measuring in areas where you want to exclude frequencies below 50 Hz. And finally, the fourth frequency range will only measure EMF sources above 2 kHz. These higher frequency electric fields are commonly referred to as dirty electricity. Included in the box is the meter with a 9-volt battery installed, the operating manual, grounding cable, warranty, and certificate of factory calibration. The ME3840B offers excellent sensitivity down to 1 volt per meter for AC electric fields, or 1 nanotesla, which is 0.01 milligauss, for AC magnetic fields. The maximum field strength it can measure is 1,999 volts per meter and 1,999 nanotesla, or 19.99 milligauss. The meter includes an auto power-off function after 40 minutes to conserve battery life, and a Geiger counter audible signal that is proportional to the measured field strength to assist with source detection. The ME3840B is a single-axis meter, which is useful for identifying sources of low-frequency EMF. To measure AC magnetic fields, set the field type switch to M, set the frequency range to 50 Hz to 100 kHz, and power the unit on with the sound option. Note the indicator in the display next to the M showing that you are in magnetic mode. Slowly scan an area and follow the direction of the highest field strength. The Geiger counter tone will also increase closer to the source. After locating the area of concern, rotate the meter in all directions and note the highest reading on the meter, shown in nanotesla. If the measured value is above 1,999 nanotesla, the display will look like this, showing only a 1 on the far left of the display. To measure AC electric fields, set the field type switch to E, set the frequency range to 50 Hz to 100 kHz, and power the unit on with the sound option. Note the indicator on the display next to the E showing that you are in electric mode. Slowly scan an area and follow the direction of the highest field strength. The Geiger counter tone will also increase closer to the source. After locating the area of concern, rotate the meter in all directions and note the highest reading on the meter, shown in volts per meter. If the measured value is above 1,999 volts per meter, the display will look like this, showing only a 1 on the far left of the display. If you wish to measure only what's referred to as dirty electricity, switch the meter to its 4th bandwidth range of 2 kHz to 100 kHz. Common sources of dirty electricity are compact fluorescent light bulbs, dimmer switches, and switching power supplies. Here, we see the meter reading these higher frequency electric fields coming from a compact fluorescent light bulb. Electric fields can be measured referenced to ground or ungrounded, potential-free. For best results, ground the meter by connecting the included 17-foot cable to a copper water pipe or to an electrical outlet using a grounding plug. For more advanced information on grounding procedures and advanced measuring tips for electric fields, please watch our Advanced Electric Field Measurement video. Once you have determined the highest readings, compare them to the latest building biology guidelines. Currently, SBM 2008 is the most recent building biology standard. A reasonable goal after mitigation would be to have levels reduced to the slight concern level as shown below. Note that nanotesla can easily be translated to milligauss by dividing by 100, so 100 nanotesla would equal 1 milligauss. For more detailed information about the ME3840B, please visit the Safe Living Technologies website at slt.co.